4.6, perform operations with complex numbers So a complex number is a number that involves I. Okay, if you're not aware of what I is, I'm getting ready to tell you, but basically I is an imaginary number. I is equal to the square root of -1, or I squared is equal to -1. Okay, so basically you get an I when you have the square root of a negative number. Okay, so some properties here of this. There's going to be two of these. If R is a positive real number, then the square root of -R is equal to I square root of R. And so an example of this, the square root of -3 would be equal to I square root of 3. So if you see a negative under a radical, you literally just pull it out. And then 2, by property 1, it follows that I square root of R squared is equal to -R. So if I had I square root of 3 squared, that would be equal to I squared times 3, or -3. Okay, so we'll be solving equations basically where you end up with a negative under the radical and you'll be pulling stuff out. So basically we'll be solving for x, and your answers will pretty much always have I in them in this section. So that'll be kind of a clue into if you've done it correctly. And the big thing to remember in this section is that when you take the square root, it's plus or minus. Okay, your answer is not complete without having both. But we'll do examples of that, and I'll remind you of that in class because that tends to be where people lose the most points with this stuff. So let's see here. I have another definition. So a complex number written in standard form is a number A plus BI where A and B are real numbers okay, and then A is the real part, BI is the imaginary part. So if I tell you to write your answer in standard form, not optional, it has to be written that way. A plus BI in that order. If you write BI plus A, I will take a point off. Okay, it has to be written A plus BI. Let's see, and then two more things under here. If B is not equal to 0, then A plus BI is an imaginary number, if A is equal to 0 and B is not equal to 0, then A plus BI is a pure imaginary number. Okay, and then an important pattern here that you need to know, okay, it will be important. You have I squared, I cubed, I to the 4th. This is equal to I. This is equal to -1. This is equal to -I. This is equal to +1. Okay? So I is equal to I squared is -1, I cubed is I to the 4th is 1. Okay, so I would say ingrain in your brain in order I -1 -I1, I -1 -I1, I -1 I1. Okay, you are going to think it's crazy, but if I ask you to tell me what I to the 27th is, this is the pattern it follows. Okay, and I can pretty much guarantee that you will be asked a question like that. So, make sure you learn this pattern that these follow. Okay, then I to the 5th repeats. I to the 5th would be I to the 6th would be -1, I to the 7th would be I to the 8th would be 1, okay, and so on and so forth. So just make sure you memorize that now. It will show up. I promise you that. Okay? Alright, so that is kind of the intro to them. So now let's look at the sum and differences of complex numbers. So we're adding and subtracting complex numbers. Okay, and I know this video is going to be a little longer, but there's a lot of notes, and I'd rather you guys get these done at home so we can spend more time doing problems in class. To add or subtract, okay, as the case may be, two complex numbers, add or subtract their real parts and imaginary parts separately. Alright, so if I'm adding two complex numbers, okay, I'm going to look at the sum first. I would have A plus BI plus C plus DI. Okay, I would want to break this up. I would want both real parts, so that's going to be A plus C. Plus, I would want to do the imaginary parts together. They both have an I, so I can pull the I out. So I'm going to have B plus DI. Then the difference, A plus BI minus C plus DI. So you have to pay attention to this minus sign here. Okay, make sure you don't lose sight of that it goes to both pieces over here. So this is going to be equal to A minus C plus, okay, the negative sign doesn't go between. It goes in between the real part and the imaginary parts, okay, individually. And then I'm going to have B minus D times I. Okay, so that's how you would add those or subtract those as the case may be if you're asked to do a problem like that. Alright, multiplying complex numbers. Okay. Okay, if we're multiplying complex numbers, we are going to use the distributive property or the FOIL method, just like multiplying real numbers. Okay, so if I have something like I times 9 plus I, I'm going to have this be 9I plus I squared. And we know that I squared is -1, so this is going to be 9I minus 1, but I need to get it in standard form, so this would be -1 plus 9I. Okay, so it follows the same method, just so you can see that, since I didn't actually write one out necessarily in letters. For then dividing complex numbers, okay, now this is a lot, but we're almost done. Alright, dividing complex numbers. We are going to use the complex conjugates So let's say I had, well actually here, let me tell you what complex conjugates are. Okay, they're going to be A plus BI and A minus BI. So, oops. If you're given this one, you multiply by this one. So you change the sign in the middle just like we do with the radicals. Okay? In the last section, I believe it was. If you're given this one, you multiply by this one, top and bottom. So if I had C plus DI over A plus BI, I would multiply top and bottom by the complex conjugate. So I have this one, so I'd multiply by this one. So it would be A minus BI over A minus BI. And so then this on top would give me AC minus BCI plus ADI minus BDI squared. And on the bottom, I would have A squared plus ABI minus ABI minus B squared I squared. So then on the bottom, so then on top, let's see, this is I squared is -1, so it's going to be AC plus BD plus ADI, or AD minus BC times I, all over A squared plus B squared, okay, because this is going to be -1, which is going to make that positive. And that's all. We'll just do a bunch of examples in class. I know this was a lot of notes, but it's really important to give us more time to do examples in class.